Okay. So we saw that when light incidents on a triangular prism, so just a sketch to give us, when you incident light at one of the refracting planes, A, B, C. So this has two refracting planes, A, B, and B, C. When you incident light at any of the refracting planes, it gets refracted at AB, and when it is, because the light is from air to glass, it will bend towards the normal, this being the refracted ray. And when the light is emerging out of the prism, it would also bend away from the prism. This is the incident, angle of incidence, angle of refraction, and so this is the refracted. And this is the second angle of refraction with regards to the refracting plane BC. This angle here is the angle of emergence. Of course, this is the emergent ray. Okay. So when we analyze whatever happens within the prism, we came to the realization that the first angle of deviation D1, which is this angle, is equal to the angle of incidence minus the first angle of refraction. Then the second angle of deviation with regards to the plane AC, D2 is equal to the angle of emergence minus the second angle of refraction. By this, we saw that then the total deviation within the prism, which is this angle DT, D total, must be equal to D1 plus D2. This, we substituted whatever we had for 1 and 2 and had I plus E minus R1 plus R2. When we analyze the whole triangle and then the whatever in there, we realize that I wish I can join these two. Yes. We saw that the angle of the prism, or the refraction angle A, is equal to the sum of the first angle of refraction plus the second angle of refraction. By this, we finally saw that then the total deviation within the prism must be equal to I plus E minus A, or total deviation plus A is also equal to I plus E. We are just reviewing whatever we saw last time, okay? It's not a proof of it, but because we've gone through it before, I'm just reviewing it with us. We express the refractive indices of the prism. The refractive indices, of course, from Snell's law, is equal to sine of I over sine of R1. This is how we can determine the refractive index. Or if we are moving from right to left, here with this relation, we are moving from left to right. The ray is hitting AB and coming out through BC. If we look at it from right to left, from ray hitting BC, emerging through AB, then the same refractive index can be obtained as sine of E over the sine of R2. Class, are you with me? Hello, are you with me?
Yes, please.
Yes, please. Hello, Frank.
Sir,
Please, the last time you were explaining the A equals R1 plus R2, I didn't quite understand on what terms R1 plus R2 be equal to A.
Hey, Frank, unless I draw it properly. So maybe somebody else also has a similar problem. So let me draw it well to address it quickly so we can move on. So these are so a proper outline of the triangular prism. This is the refracting angle A, and it is unique for different glasses prisms. So when you incident light at one side, and because we are incidenting light, this normal must be perpendicular to the refracting plane. So the line is a normal N1. Let's incident light at AB. So this remains the angle of incidence I. Of course, the light is from air to glass, so it will bend. Will it bend towards the normal or away?
Towards.
Okay, so towards the normal. So within the prism, this becomes the refracted ray. This is the first angle of refraction, R1. Now, when the ray is coming out of the prism, it would enter into a less dense, from a more dense medium to a less dense medium. So it will deviate away from the normal this time around. That's a normal. So the second normal with regards to N2, and we expect the ray to deviate away. This is the angle of emergence. This is the second angle of refraction, R2. Let's extend this the two normals to join. Okay. Then this is the part of the original part of the incident ray. Let me extend it. This is also the original part of the emergent ray. The two rays, so this becomes the first angle of deviation D1. This also becomes the second angle of deviation D2. This angle between the incident ray and the emergent ray is equal to the total deviation within the prism, D total. Okay. If D1 is equal to I minus R1, D2 is also E, the angle of emergence, minus R2. Frank, are you okay?
Yes, sir.
Okay. Then, if this is the case, then we can argue out that the total deviation within the prism, which is this whole angle, must be equal to d1 plus d2, which is that. So I plus E minus R1 plus R2. I think your confusion is here, how R1 plus R2 becomes A. Okay, so we first considered, assuming this is OA, let's call this as E, and then let this point be F. So when you consider this quadrilateral OAEF, OAEF, because this whole angle here, this whole angle here is equal to 90. Don't forget this is the normal, so the normal must always be perpendicular to the surface. It means this is the second normal. This is also equal to 90. Okay, so 90 plus 90 is 180. In that case, it also means that this angle plus A, the refraction angle A, must also give us 180, so that they will add up to these ones to give us 360. Okay, so angle A plus angle F must be equal to 180 degree. Frank, are you there?
Yes, please.
Okay. If that is it, when you consider the triangle, considering triangle O, O, E, F, sum of triangles, sum of angles in a triangle must give us 180. So it means that angle R1, the angle R1 plus the angle R2 plus the angle at F must also be equal to 180. Therefore, you have equation 1 and also equation 2. Make F the subject in equation 1. Come and substitute that into equation 2. So F in equation 1 is equal to 180 minus A. Therefore, when we substitute that into equation 2, we have R1, R2 plus 180 minus A, giving us equal to 180. When you make A the subject, you have A giving you R1 plus R2. Frank, this is the proof.
Sir, please, can you also just equate A plus F and R1 plus R2 plus F, like at the beginning, and make A the subject?
In that case, you need to equate it to 360. Don't forget.
Okay, sir.
This is 180, 90 plus 90 plus A. So 180 plus A plus F must be equal to 360. And you get the same relation as this, as equation 1. Are you okay?
Yes, please.
So that's how come we got this important equation. Meaning that in case you don't know the refraction angle of the prism, it is equal to R1 plus R2. Okay, so we can therefore express the total deviation to be equal to D1 I plus E minus A, or deviation plus A is equal to I plus E. Yes. Please, is there any other question? Okay. Then we looked at minimum deviation. And the minimum deviation thing, we saw that as the angle of incidence increases, as angle of incidence as I increases, the deviation, which is the total deviation within the prism, would also decreases. So as I increases, D total also decreases. When it decreases to that least value, from there, it increases again. So example, if we are increasing I, table of I against total deviation, assuming I'm progressively increasing I by this, you also have the total deviation decreasing from its maximum value. Let's assume that its maximum value is 70. When I increases to 20, it will come to maybe 60, 50, 40. When I is 50, it will decrease to 30. Then from there, as I increases, D begins to increase. So instead of this decreasing to 20, it will begin increasing to 40, even though I is being increased. So 60, 70, it will come to 50, 80, it will come to 60, 90, it will come to maybe, it will come to 70. Okay, this value of 30 degree becomes what we call the minimum deviation. Minimum because it's the least value of deviation with regards to these values or numbers. Okay, and when we get to that angle of incidence, which gives us the minimum deviation within the prism, what happens is that the incident ray at the minimum deviation, what happens is that the incident ray passes through the prism symmetrically. So that is the first thing which happens at the minimum deviation. So in OBG or objectives, you can be asked what happens to the incident ray at the minimum deviation. Then the possible answers can be this: the incident ray passes through the prism symmetrically. That is one. And two, that is the point where the angle of incidence become equal to the angle of emergence. So that's the only, for refraction of light in triangular prism, it is the only point where I is equal to E. And finally, the first angle of refraction, R1, is equal to the second angle of refraction, R2. So these are what actually occur at the minimum deviation. Class, is there any question? If you have any question, quickly ask whilst I take attendance. Yes, John, could you?
Sir, please. This is my first time joining the class, so I don't really understand what you guys are doing.
John, It's a continuation of what we did last week. I'll send you the video to this, okay?
Yes, sir. Thank you,
The
sir.
first the meeting we had, and then we'll also send this as well so that you can
Okay.
quickly review. So if you are joining us for the first time, please don't worry. Just give me a hi after the meeting. I'll send the previous video.
Okay. Thank you, sir.
Okay. Please give me a minute. I'm coming. Hello. Hello.
Sir, please, I'm sorry.
Okay. Hey, who is Cole Palmer? Because the Cole Palmer that I know plays for Chelsea.
That's a fake one.
Fake Cole Palmer. Okay.
The one here is the fake one.
Maybe the original one is fake, rather. I just want to drop attendance quickly. Okay, so R1 is that. Then we can also use these conditions at the minimum deviation to find the refractive index. Refractive index is actually sine I over sine of R, either R1 or R2. But at the minimum deviation, we've seen that, you see, the expression for the total deviation is this. D total is I plus E minus A. At that least value of deviation within the prism, the total becomes the minimum. So D minimum becomes I plus E minus A. Then we make I the subject. I as the minimum deviation plus the refraction angle. Okay. Hold on. At the minimum deviation, because I is equal to E, because the angle of incidence is equal to the angle of emergence, this will become 2 times I. We will only have an incident ray, not different in I and E. They will be the same because I is equal to E minus A. So that when we make I the subject, we have I being equal to D minimum plus A all over 2. Then at the minimum deviation, R1 is equal to R2. So what will happen is that A, which is equal to R1 plus R2, A will just be equal to 2R because they are equal. R1 is equal to R2, so they are all equal to R. Therefore, R is equal to A over 2. So you substitute whatever you made for I and R into this subject, into this equation to find the refractive index. So sine of dm plus A all over 2 divided by the sine of A over 2. This is using the condition at minimum deviation to find the refractive index of the material. And it will not be different from if we are not finding the refractive index when we are not yet at the minimum deviation. Class, are we okay? Are we okay? Last thing. When you plot a graph of the total deviation, a graph of the total deviation against the angle of incidence, gives us a graph which you must know. It's a must thing you must know, because these are tested in our physics practical. Last year, physics practical, they had a question on this. Did I say that last year? This year, in one of the odds, there was a question on this. So a graph of the total deviation against I is rather the other way around. Let me make it, as for graph, it can also be that, but let me make it I against the total. When I is 0, when angle of incidence is 0, we have the maximum deviation within the prism. So it will give us this value. So when I is 0, oh, hold on, I think I've rather interchanged this. The total against I. When I is 0 over here, this is a point where I is 0. We have the maximum deviation within the prism. As I increases, what happens to the deviation? From the theory, we are seeing that as I increases, D must also decrease. So if we have a graph such that as I increases, this must also decrease, this will be the expected values. This is maybe increasing to 10, 20, 30, 40, and our expected value for the deviation is that it must also be decreasing. It will decrease to a certain point. Then as I increases, we'll have an increasing value of the total deviation. So assuming this is 40, it will begin to increase. 50, it will also begin to increase. 60, it will begin to increase. Then to the last value. So a graph of total deviation against the angle of incidence would give you a curve. Which will look like this. Must actually give you a curve that decreases, gets to a minimum value, and begin to increase. Plus this graph is very, very important under refraction of light in triangular prism. So please take note of this. Now this angle of incidence, which gives us the minimum or the least deviation within the prism. So when you trace the angle of incidence to this must give us the minimum. And at this angle of incidence, I must be equal to E, 2, R1 must be equal to R2. Okay, so this is a graph of minimum total deviation within the prism as against the angle of incidence. Please, is there any question? Yes, Joshua.
Please, the graph, can you use the assignment to make an example so I can understand it?
No, the assignment is a different it's a different concept. That's an I think triangular rectangular prism. This is an triangular. So I'll give you a practical question on this, so we could test whatever we have. Frank.
Please, I thought you said that the angle of incidence can't be zero. Otherwise, the total deviation won't like it will also be.
You understand what I mean later. I will give a question and it will help you bring that way. Okay. I understand what you mean. Please, is there any other question? Another hand is Gideon.
So when you are writing the values on the total deviation side, are you supposed to start from a minimum value or are you supposed to start from the maximum value? Starting from the I is 0 from that side.
The theory is that as I increases, the total deviation must decrease. So you will be given a lesser value of I in that increasing order. Okay. And as you conduct the experiment, what you must expect is that as I increases, the total deviation will be decreasing. It will decrease to a least value. And even though I is being increased, and then begin to increase again. That's why you okay?
So, can you label the total deviation side so that I can get to the practical example of what you're saying?
This is a graph of the vertical is the total deviation as against the horizontal is the angle of incidence I. Okay, and I started increasing the angle of incidence from 0. We have the maximum deviation, then to 10. I'm just guessing values. Okay, then to 10. Angle of incidence increases to 10, and this will be the point for the total deviation. When I is 20, this is how you can read total deviation or the deviation. And when it comes to this angle, which is close to 30, then we have the minimum deviation. So the angle of incidence 30 seems to be giving us the minimum deviation. Then as I increases, the minimum begins to shoot up instead of decreasing. Are you okay?
So from the angle of incidence, then mapping into the total deviation, you can have, let's say, 70 over there or something. Or
Yes.
50.
Yeah,
Then
so
I see.
I'm increasing it gradually, 10, 10, 10, 10. So this can be 50. This can also be 60, 70, because the idea is we are increasing it. Don't forget, I'm only figuring out values for this purpose. They are not actual values. Are you okay?
Okay, so please, can you put values at the total deviation side so that I'll understand well?
So let me use the same values so maybe 70. So this can be, when I is 0, this can be 70, 60, 50, 40, 30, 20, 10, and then 0. Meaning that as we increase I, total deviation is also decreasing. But when I is 0, 70. When I is 10, we have 50. When I is 20, we have 45, blah, blah, blah. Are you okay?
Yes, sir, I'm okay now. Thank you.
All right. Okay. So the first question. The first question. A ray of light incidents normally on a triangular prism. Please, I think I've sent the question to the page. I think it's the second question. I want to open to it and then. So please open the PDF file on the page. A ray of light incident normally on a triangular prism. Question 2. Of refracting angle 30, meaning the angle of the prism is 30 degrees. The ray is incident normally on the triangular prism. Yes, Frank. Hello, Frank. Okay. So we have this triangular prism. Its angle, the angle of the prism is 30. For the sake of those of you using laptop, please, I'm reading. A ray of light incident normally on a triangular prism. A ray of light incident normally on a triangular prism of refracting angle 30. So the angle of the prism E, we are told, is 30. What is the maximum deviation? What is the maximum deviation within the prism if the refractive index of the prism is 1.5? What is the maximum deviation within the prism if the refractive index of the prism is 1.5? So we are told that the refractive index is 1.5. And the question demands the maximum deviation. We are also informed that the ray incident normally. So let's draw a normal to one side. If this is the normal, the ray is directly or exactly along the normal. So this is the incident ray. The incident ray makes an angle of 90 degrees with one of the refracting planes, AB. Okay, AB. Now, if the incident ray makes an angle of 90 with this side, what will be the angle of incidence? Or what is the angle of incidence? Anybody? Anita, if the ray makes an angle of 90 or is normally to AB, what will be the angle of incidence, Anita? Nanakumi? Elidia?
Yes, please.
If the ray is normally to the plane AB, what is the angle of incidence here? Okay, Echo want to help. Yes, Echo.
Sir, please, is it 0 degrees?
That is 0. Okay, so when the ray is perpendicular to the plane, the angle of incidence is 0 because angle of incidence is the angle between the normal and the incident ray. but they are all parallel. So the angle between them is 0. Okay, so under this condition, I is 0. Now, when I is 0, the ray would go undeviated at the refraction plane AB. So, Frank, because the angle of incidence is 0, or the incident ray makes an angle or is perpendicular to AB, it goes undeviated at AB. However, when it hits another plane, you see there's another edge BC. This time around, if we draw a normal, it doesn't make an angle of 90 with BC. And because the angle to BC is not 90, this time around, when it is coming out, it will deviate. It will deviate and deviate away from the normal. Frank, are you okay? So it means that
why it's 0.
Oh, it's 0 because you see the normal, it is like, let me use a different color. Assuming this is the normal is always perpendicular to the plane, and the light incident ray is along the same normal. Okay, so if they are parallel to one another, what is the angle between the normal and the incident ray, Saki?
So I didn't know that it was the angle between the normal and
Angle of incidence, angle of refraction, reflection, these are all measured from the normal. Are you okay? So at the boundary BC, because it isn't making an angle of 90, it will deviate. And how will it deviate? Away from the normal. Away from the normal. And this is what will give us the emergent, this is the emergent ray. Okay, and this is the angle of emergence. If we trace the emergent ray backwards, if we trace this backward, we have the deviation at the boundary. So we'll have this as the angle of deviation. Please, are you okay? Class, are you okay? All right, so because I is 0, R1 is also 0, because if it is not bending, the ray is not bending here. Then with regards to the side AB, there wouldn't be any deviation. So R1 would also be 0. R1 would also be 0. Are you okay? Then this angle between the two, this will be R2. R2 from the normal to the original part of the incident emergent ray. This angle between the emergent ray and this will give us the deviation. So let me correct that. This will be R2. Now, using A is equal to R1 plus R2. If R1 is 0, then it means that under this condition, R2 will be equal to A. So if A is 30, then R2 would also be 30 degrees. The question asks that we find the total deviation. Total deviation dt is equal to I plus E minus A. That's the equation we had, okay? I is 0, so it means that the total deviation will be E minus A. We have A. We don't know E. How do we determine E? We can determine E by either moving from air to glass or from glass to air. If we want to move from air to glass, then the refractive index, which is sine of E over the sine of the second angle of refraction, R2. Please, we are moving in this direction. As I said, we can move from air to glass or glass to air. Whichever way we look at it must give us the same answer. The refractive index is 1.5. 1.5. This is equal to sine E. E is what we are looking for. R2 is 30, so sine of 30 degree. Please multiply 1.5 by sine 30 and then give me the value for sine E. So 1.5 by sine 30. Sine 30 is 0.5. Yes, I'm waiting for you. Calculate this for me. Help me determine the value of E.
0.75.
I mean E, not sine E. E. I understand you. Sine E will be 0.75. Therefore, E will be equal to
48.59.
so 48.6 degree. Okay. Because this is an angle of 8.6. Therefore, so once you have the angle of emergence, or let's look at it from glass to air. If we are moving from glass to air, don't forget this will be the reverse refractive index. Okay, so 1 on n, the refractive index will be equal to sine of R2 over the sine of E. If we make sine E the subject, the value is the same. Sine E will be equal to the refractive index times sine of R2, which is R2 is 30. So it will give us the same value as we got. Okay. And so once we have the angle of emergence, then the total deviation, D total from here, S, E minus A, and E is 48.6 minus A, which is 30. Therefore, we have 18.6 degree as the total deviation under this condition. So that is the solution to the question. Please, are we all okay? Saki?
I thought it was 30 degrees.
Yes, A is 30.
I said sine R was sine 30.
So sine R2 will be sine of 30. Don't forget, because R1 is 0, we got R2 from here. Saki, look at it from here. There's the equation linking A to R1 and R2. And because R1 is 0, R2 will be equal to A. That is how come we got R2 to be 30. Frank?
If a ray incidents normally on the glass, it means that the angle of incidence is
Frank, speak up.
Please, I said if like a ray of light incidents normally, does that mean that the normal is 90 degrees?
Normal is always 90 to the plane. So to every surface or boundary, if you draw a normal, it must make an angle of 90, okay, to it. So assuming this is my normal, making an angle of 90. And this is my ray, also making an angle of 90. Because angle of incidence is always measured from the normal, the reason why we seems to be combining or putting both together. Are you okay? And so this angle is always measured from the normal. That is why we are putting them together. And if they all make an angle of 90 to the surface, then it means the angle between them is 0. Frank, are you okay? All right. Let's look at the second question. A ray of light incident normally on an isosceles right-angled prism. I'm reading question 3. A ray of light incident normally on an isosceles right-angled prism and travels as shown in the figure. It travels as shown in the figure below. Calculate the least value of the refractive index of the prism. Calculate the least value of the refractive index of the prism. Please, the diagram is what is drawn below. The diagram describing the question is this. We have a right-angled triangular prism. The angle to this is 90. The refraction angle, this is 45. This is also 45. So please, under this question, A is 45. A is equal to 45 degrees. Then the light travels perpendicular to the plane to this side. So it makes an angle of 90 to this side of the prism. Let me use letters A, B, C. So it makes an angle of 90 to AB. Okay. Then it reflects within, total internal reflection. It reflects within the question is that we have to determine the least value of the refractive index. What will be the least value of the refractive index? So 3 minutes, let's think through this for 3 minutes. We are given the angle of refraction, which is 45. Total internal reflection goes on within the prism, meaning if we draw a normal to this side, the angle of incidence must be greater than the critical angle. So this angle of incidence here must be equal or greater than the critical angle. So three minutes to try. Whilst I look for another question. Can I clean this solution? The first solution.
Yes, please.
Okay. Okay, so for the sake of time, you see, the light, incident light is internally reflected, meaning it is not coming out from the prism. The light stays within the prism. What is the condition? Let's see if the conditions for total internal reflection is adhered to. One, light must travel from a more dense medium to a less dense medium. So once this surrounding part, okay, is air, it qualifies. Two, for total internal reflection to occur, the angle of incidence in the more dense medium must be equal to the critical angle. Okay, must be equal to the critical angle. So the angle of incidence in the more dense medium must be equal to the critical angle of the material. Now, what is the angle of incidence? Once the ray incident on the prism perpendicularly, I is 0. If I is 0, then R1 would also be 0.
So this can come again.
Once the light incident perpendicular to AB, angle of incidence is 0, meaning the light will not deviate at this boundary AB. So the first angle of refraction is also 0. Okay, so to boundary AB, because I is 0, R1 is also 0. This refraction here, this angle here is equal to R2 at the boundary AC. But for AB, I is 0 and R1 is 0. Are you okay? So if this is the situation, then using A is equal to R1 plus R2, straight away R2 is equal to A. And for the light to reflect internally, the angle of refraction in the more dense medium must be equal to or greater than the critical angle. So R2 would be equal to C, the critical angle, as well. Ask questions here if you are not so clear.
Well,
So this I'm not too clear.
Okay, so
actually, but that is how.
let me draw.
Uh,
This is 45. 45. Light incident at one side, just as we saw. And within, because this is the incident ray is 90 to this side, angle of incidence 0, The first angle of refraction R1 is also 0 or at this plane AB. So supposing this is A, B, C, I is 0 here and R1 is also 0. To the side AC, this angle, don't forget the light is internally reflected. This angle is actually R2. This is R2, okay? So using A is equal to R1 plus R2, R1 is 0, so automatically R2 is equal to A. Now for the light to internally reflect, what is the condition? The angle of incidence in the more dense medium, R2, must be greater than the critical angle of the material. Is that okay? Must be greater than the critical angle. But the requirement for total internal reflection is that if you are able to determine the critical angle, then you can adjust the angle, the angle of incidence in the dense medium so that it will reflect within. So the least value is that, okay, if R2 must be greater than C, then the least value is that R2 must be equal to C. If R2 is equal to C, you can determine what that adjustment which will create total internal reflection. So this equal to 10 must be the least. That is how come we are equating R2 to the critical angle. But already, we also, from this equation, we know R2 is equal to A. So if R2 is equal to A, then it also means that the critical angle C is equal to A, which is also equal to 45 degrees. Are we okay?
Yes.
Then the refractive index becomes 1 sine C is equal to 1 over the refractive index. So you use this to find the refractive index of the material. And since we have determined the critical angle, we can easily find the least refractive index of the material, which will be 1 over sine of C. Please calculate the refractive index for me. If we have C, help me determine the refractive index.
The 1.41.
Give it to me in sets.
√2.
Root 2. Exactly. So sometimes in objectives, we can be expressing these values in sets. Okay. But don't also forget that root 2 is the same as 1.414 approximately. Okay. As for this, I'm going to give you a last one. And I expect each one of you to be able to do this. I'm reading. A ray of monochromatic light, monochromatic light is incident on one refracting face of a prism. A ray of monochromatic light is incident on one refracting face of a prism of refracting angle 75 degree. Of a prism of refraction angle 75 degree. So this time the refraction angle is 75 degree. It passes through the prism. and is incident on the other face. It passes through the prism and is incident on the other face at the critical angle. It passes through the prism and is incident on the other face at the critical angle. At the critical angle. Edia, Ashima, mute yourself. If the refracting index of the material, if the refractive index of the material of the prism is √2, if the refractive index of the material of the prism is √2, what is the angle of incidence? What is the angle of incidence on the first phase? What is the angle of incidence? What is the angle of incidence on the first phase of the prism? A ray of monochromatic light is incident on one refracting phase of a prism of refracting angle 75 degrees. It passes through the prism and is incident on the other face at the critical angle. If the refracting index of the material of the prism is √2, root of 2, I mean this, √2, square root of 2, what we are familiar with. What is the angle of incidence on the first phase of the prism? In fact, whoever gets this right will be awarded. I'm giving you 7 minutes. It's 12:43. It's 12:43. Start with 7 minutes. So at exactly 12:50, I'm coming your way. The problem of the day. Let me go for commercial break. I'll be with you.
Yeah.
Hello.
Please, what are you supposed to find?
What is the angle of incidence on the first phase of the prism? What is the angle of incidence on the first phase of the prism? Note that you were not told that the angle, the ray incident normally, no. A ray of light, a ray of monochromatic light is incident on one refraction phase of a prism of refraction angle 75. So the refraction angle A is 75. It passes through the prism and is incident on the other face, meaning once it's not normally, we are not told it's normally, so it will bend and pass through the prism and incident on the other face at the critical angle. Okay, so it hits at the critical angle. If the refracting index of the material of the prism is √2, find the angle of incidence on the first phase of the prism. Don't use ChatGPT, I beg you. Let's understand, I beg you, okay? Let's understand how we can solve it without using AI. AI can solve it for you, yes, but because you may not understand, whatever you get wouldn't be relevant. So let's apply our thoughts what you've learned to solve it, and we can continue. Okay.
Okay.
Water levels rising fast, and will soon completely submerge the room. Ideally, you don't put it completely in the toilet, but as soon as he speaks, the water reaches the heat. Everyone frantically swims toward the toilet, except for one agent who swims toward the door. He knows water pressure keeps the door sealed shut. Meanwhile, the others reach the bathroom. They quickly detach the shower head and plug the hose team in the toilet. At the same time, each of them wants the toilet, so soon for a glass window. Cracks in the faucet below and immediately punching the glass. To here and broken strokes, the glass shatters immediately. This was a test organized by the Supremos, those who passed into the next stage, and those who failed not to respond on starting challenges to come. Agency test is a high altitude jump, adverse bias and jump without hesitation. However, the instructor announces that since emotions is faulty, this pilot is destined to die. To save everyone, one agent suggests they link hands in a circle and open their parachutes one by one. But each time someone confirms their parachute is working, they abandon their teammates and pull away. Eventually, only two people are left, facing and landing. They can only trust each other, they hold each other tight, and open their parachutes simultaneously at the last moment. Both land safely. The instructor tells them the test wasn't just about courage, but about teamwork. Those who betrayed their teammates would be eliminated on the spot, as they weren't fit to be agents. Why the fuck did you choose me? I expected what happened on the The instructor then opens an agent's backpack, revealing that all of the parachutes were perfectly functional. The true purpose of the test was to eliminate the selfish individuals. Clearly, the test was a success.
You have 3 minutes.
Other plans. He pulled off a move that left the man completely speechless. But wait, what superpower will you choose? Copy the plans, ignore, super speed, like flying, comment the heart, teleportation, subscribe, time travel, everything is shared with 3 friends. Now look.
Okay, so back to you. How far? Your 7 minutes is over. How far? It's 12:52. Has somebody been able to solve the problem? Obama, please mute yourself. Elikem,
Please add I to be equal to 75.4 degrees.
75.4.
Yes, sir.
Who else? So that is Yasmin.
I see.
Come again.
45
Yeah, 45 CD.
degrees.
Oh, okay. You also had 45 degree. Who else? Asima,
Yes, I also have 45.
you had 45. Elika, what's your answer?
75.4.
45.4, so 45. Gideon, last contribution from Gideon.
I said 75.
70. Elika, you said 75.
And 4.
Okay. Gideon.
So I think 67.5.
Okay, let's solve it. Thank you. So I'm not declaring any winner for now. Let's all solve it and then. So the question says a ray of light is incident on one fracting face of a prism of refraction angle 75. So let's draw. So this is 75. A, B, C. Light is incident here. We don't know the angle of incidence. So this is I. Then from air to glass, it will bend towards the normal. So we'll deviate. Then from glass to air, we are told that and it's incident on the other face at the critical angle. So once the refracted ray hits the critical angle of the material, what happens? Yes, class, what will happen? If the refracted ray hits the critical angle, what will happen? Can somebody help?
Yeah, it will reflect backward.
It will.
Reflect backward.
Yasmin, I won't buy it. We are told that it hits on the other face at the critical angle. Yasmin, at the critical angle, what happens? Eh? The what?
The refracted ray rather reflects back.
So the refracted ray will be on the boundary between the two media, or the angle of refraction must be 90, right? So it must be here. The refracted ray must be here. So that,
So this how?
what is the critical angle? Is that angle of incidence in the more dense medium that produces an angle of refraction of 90. Okay, so this angle must be 90, meaning that this angle R2, this is R1, this is R2, and R2 in this case must be equal to the critical angle of the material. If it's hitting at the critical angle of the more dense medium. Please, are we okay? Class, are we fine?
Yes, please.
Okay, so A is equal to R1 plus R2, which is actually the critical angle of the material, C. Okay, R1, we don't know. But then we can find R2 in order to determine R1. How do we determine R1? We are told that the refractive index of the material is equal to root 2. Therefore, the refractive index is equal to sine of 90 over sine of R2, which is the same as the critical angle. And if we have the refractive index, we can easily find the critical angle. So help me find C. Help me find the value of C. So sine C is equal to 1 over root of 2, or is the same as root 2 on 2. Therefore, C is equal to, is that 45 degree? Is that 45 degree?
Yes, please.
Good. So it means the second angle of refraction, this is also equal to R2. Since A is 75, then it means that R1 is equal to A minus R2, which is C. So 75 minus 45 would give us the first angle of refraction, and that is 30. So R1 is 30. R1 is 30. If R1 is 30, yeah, Saki.
Yeah, because I'm still confused how R2 is equal to C.
You see, we are told that when the ray passes through AB, the first phase, and then hits the second phase, okay, the angle of incidence at the second phase is equal to the critical angle of the material. So R2 is equal to the critical angle. If R2 is equal to the critical angle, then the refracted ray would be on the boundary between the two media, air and then glass. Are you okay? So the question told us that the angle of incidence at the other refracting plane is equal to the critical angle, the reason for which we have R2 being equal to C. Saki, are you fine?
Yes, please.
Okay. So once you have this, you have R1, you can use refractive index is equal to sine of I over sine of R1, okay, to find I. So root of 2 is equal to sine of I over sine of R1, which is 30, okay. Therefore, sine I is root 2 times 0.5. And what's the product of root 2 and 0.5? What's the product of root 2 and 0.5? Hey, Anita and Co. Saki, come again.
Root 2 on 2.
Root 2 on 2. And once sine I is equal to this, obviously I is the sine inverse of root of 2 on 2, which is equal to 45 degrees. So how many of you got 45? Show by hands. Nobody. Saki, hey, Asima, Yasmin, Michaela, Michelle, Janelle, wow, blessing. Oh, okay. Then I'm really blessed. I'm really blessed. Okay, so this is, I'll send you another question for today. Okay, try your hands, a bit trouble question. I'll increase the level of difficulty a little bit. Try your hands, we'll discuss it on Thursday. Then we move on. Now, we have about 12 minutes for the practicals. In the practical, you see, one, you were asked to, I gave you I values, R, partially filled for sine I and sine R. These are easy work to do because you've been given values. Sine I, sine R are calculated values. Then I saw some of you considering this ratio sine I over sine R. And then you got different values. Still, I saw some of you finding the average of the values they got for this ratio, sine I and on sine R. Then they will sum them up, divide by 5, and then tell me that the refractive index is so and so. This is wrong because you were given instruction. The instruction was that after finding sine I, sine R, plot a graph of sine I on the vertical against sine R on the horizontal. So I was actually expecting that you plot this information on a graph sheet.
I'm on your platform.
Blessing, you are on my platform. So I was expecting you to plot this. And in plotting graphs, please, you must label your axis, sine I. Your vertical axis is named as sine I. Your horizontal axis is also named as sine R. These values which you had are what you use in plotting the graph. Now, the time we have at our disposal isn't much. I would have considered the values so that guide you to pick scales and all that. We'll do that another time. Maybe on Thursday, we'll spare 15 minutes and do that. But then, when you plot your points, you see, I saw some of you making these points. Of course, one point was far displaced from the other, and you were asked to determine the incorrect value also. Clearly, once this is deviated from this plotted point, it means that is the odd one, okay? How do you plot this point? You see, unfortunately, you were not able to have values that could match one another directly. Okay, if you had that, the best way out is to use a straight edge to join this point. But it's not like that. Okay, but you still need to plot this to have to calculate the slope and all that. So how do you do it? You consider the line of best fit. What is the line of best fit? Assuming these are my plotted points, you see, look at those lines which could accurately join, about 2, about 3, okay, and draw the line either from the origin, or if there's a question on intercept, you can also pick it to cut the vertical or the horizontal axis. But you were not asked to find any intercept. So pick it, draw those few points which could accurately join from the center to get a straight line. However, as you do it, if it happens that you have about 2 points which wouldn't join, assuming this two, I can only have these two to join. The moment I draw this line and these two, this even 3 are skewed to one side, they are all okay at one side of the straight line, what you are calling as your line of best fit, it means your line is wrong. How do we do it best? You have to draw your line of best fit in such a way that other points which could not join will be distributed around the line. So the best way out is that if I pick it this way, at least I have 1 here, I have 1 here, another 1 here. This is accepted. But you should not draw it so that other points will be skewed to one side of the line. Please, are you there?
Please come again.
Okay, for the sake of time, we have just 5 minutes to end the lesson. Okay, I'll revisit this on Thursday. Then let's come to the slope. In our theory, we saw that the slope of sine I against sine R is equal to the refractive index of the material. So this is, I wanted you to use the graph to find the refractive index and not to find this constant and then find the average. No. Plot your graph, get a straight line and pick any 2 points on a straight line for your slope. So if I'm choosing these 2, then the change in the vertical against the change in the horizontal would give me the slope. Or if you take the tangent of this, tan of the angle theta is the vertical opposite, which is sine I over sine the horizontal, which is sine R. So this is the same as the slope or the refractive index. So the slope of this graph must actually give you the refractive index. Please, are you okay? Are we okay? Then we were asked to find R when I is equal to 45 degree. If I is equal to 45, what will be the corresponding angle of refraction? So since this graph is sine I against sine R, find sine of 45 degree. Sine 45 is equal to 0.7071. Come and then plot this sine I value on the graph. So you locate the point 0.7071. Plot it, trace it to the line, and then match it to its sine r value. So if 0.7071, what will be its corresponding sine r value? If you get the sine r value, let's assume you had give me any value 0.680, then r will be equal to the sine inverse of 0.680. Some of you also considered an alternative approach, which was on point. If you could use the graph to get the slope well, the slope represents the refractive index. So S is equal to this. Therefore, since Snell is saying that sine I, refractive index is sine I over sine R, you are given I. So sine of 45 divided by sine of R. Then equate it to that value of slope you had. This must be around 1.49 or 1.5 something. Equate it, and you can also use that to find the angle of refraction. Please, is there any question? Is there any concern? Saki?
Please, for the slope, what if we take any 2 points, like the sine of I and now we take only 2 points, then use it to find like the change of y over the change of x.
You mean these values of sine I and sine R?
Yes, sir.
That is wrong in the sense that when you do that, you are only doing that for one angle of incidence and its corresponding angle of refraction. But you see, that is why when some of you, when you took the ratio, you got 1.49, 1.5 something, which one will you take as your refractive index if this is your approach? Okay, so plotting it on a graph gives you the average value of all the points given to you. So Saki, you must use the graph, find the slope to get the refractive index. Are you okay?
Bro, sir, I mean, like, you see, you have plotted the graph
Yes.
and you have used 2 values to get 1 point on the graph.
Yes.
Yes, so
So
say I understand that the values for 1 point, so you pick any of the 2 points and the values.
exactly. In doing that, I pick 2 points on the straight line, this one and this one. Determine the change in the vertical between these two selected points. Also determine the change in the horizontal between these two selected points. That is how what we do in determining it. Okay, so you can pick any 2 points on the straight line, but we always advise that the 2 points must be spaced out. You shouldn't pick close points. Example, this, and you use this to find the slope. No, that is not accepted. Saki, are you okay?
Yes, sir.
All right. So we will go back to this. It's very important because when I marked, I saw that a lot of you had issues with rotten out. Yes, Gideon. Gideon, hurry up, your time is gone.
Okay, is it advisable to convert the points into whole numbers before you plot them?
You can. I will talk about that, how you can reorganize your values to be able to choose your slope easily, your scale easily. Okay. So I'll talk about that. All right. So our time is up. It's a minute past our time. So this is where we end today's meeting. We'll continue on Thursday. Is that okay? Please spend time to go over the assignment we solved today. I'll forward another set of assignment, but go over this. Okay. All right. Bye bye, and you hear from me on the page. All right. Yo.
Bye, friend.